Hello and welcome to this talk on CI/CD at scale, not the pain. Now, before we go on, just as a quick means of asking questions, the kind of folks here have proficient us with Slido. I know that in a group setting like this, individuals may not feel comfortable asking questions out loud, and it's such a wide audience. You can pose your questions here, and I'll do a review of them at the end. If I don't answer any of them, you can hit me with a stick. Equally, if you're not even comfortable doing that, I will be hanging around afterwards. Feel free to come up to me after the talk and have a chat, answer questions. Maybe the question you posed is a 20-minute talk in and of itself, in which case, probably best to answer that after the talk. And before we just go on, because I forgot to do this in my last talk here, I should probably introduce myself. So, hello, my name is Ben Clark, or Benjamin if I do something wrong. I'm a DevOps contractor. I have been for 12 to 13 years. I tend to operate in more medium and larger organisations, so sort of your big multinationals across both public and private sector. And yeah, so I tend to operate at that much larger scale. I tend to be in the web space, sometimes the embedded space, just a little bit of everything really. And just to go through what we're going to do, I'm just going to give a brief overview of terminology, just so everyone is sort of aware of the words that I'm using, and they're not just sort of arbitrary letters that mean nothing. And then I'll go over some common CI/CD scaling pains you can get, and then some ways you can go about combating them. Yeah, all of these things we're going to talk about today have been tested by myself with various clients of mine, otherwise we'll be talking about them. And yeah, in terms of scale, just to sort of give some context for that, the scale which I'm talking about here is a couple of thousand pipelines and maybe 8 to 12,000 builds a month. So that's the sort of scale that I'm talking at here. It is applicable to lower scales, obviously, but we'll get onto things like essential complexity and over-engineering and all that stuff, which is something I'm sure we've all been accused of. So, yeah, just a brief overview of terminology, because I don't want to do the whole talk about what CI/CD is. We're going to talk about it at scale, but you should at least know some basics. So, the concept of continuous integration is that if you have changes coming in from multiple authors or multiple different sources, you want some way to automatically make sure all of that plays nice together. It's almost like you want to make sure it integrates instantly. And so that's things like if you're doing commits and pull requests, you're doing quality changes, you're doing regression testing, you're doing all that sort of stuff. It can also cover things like end-to-end tests that are automated in your environment as well. Then you've got the concept of continuous deployment and continuous delivery. When people talk about CD, not many of them realise there's actually two things that means. Continuous deployment is the idea that you have an automated pipeline to release your production candidate into production, however you deem that ready for release. Right? That might be you've merged your commits onto the main branch, you deploy it automatically. It might mean you've semantically versioned your product and then you deploy it automatically. The key thing about continuous deployment is that it's continuous deployment. So as soon as that release candidate is ready to go, it ships out the door in an automated fashion. Then you have continuous delivery, which you might not see because I'm standing in front of it, but if I stand here, you also can't see, so I'm standing here. Continuous delivery is the idea that if you have a continuous deployment pipeline, that's all good and well, but you may want some safeguards, right? You might want to release to production continuously. You might want, for example, if you're an IT house, you might want to put in a change request that has to be filled out and approved before you actually do your deployment. That's where the concept of continuous delivery comes in place, and in my experience, it's a lot more common than continuous deployment because you tend to want those audit trails, you tend to want that accountability. A difference might be you're doing a Terraform apply automatically in continuous deployment. With continuous delivery, you'll be doing a plan, a human being will review that plan, approve it, and then it will deploy. Still automated, just a bit of safeguards in there. Then have the concept of pipelines and builds, which are essential to this scaling. So a pipeline is simply just a static artifact of a bunch of steps which, when they are performed, fulfill some kind of business need, right? And those pipelines are hopefully generalized with inputs and parameters and all that sort of stuff. The instantiation of that pipeline at runtime to actually do a thing is the build. So a difference might be you have a pipeline to deploy something. As an input that says you're going to deploy this in either the data center in my mum's shed, or I'm going to deploy it in the data center down the road in Bob's house, right? The pipeline will be generalized to have those inputs. The actual concrete build will have finite parameters with discrete values, so it actually does a singular thing. So hopefully, because I saw a lot of nodding heads, with all of that actually understood, we sort of have a base level idea of what CI/CD is, without going too much detail. We actually talk about what it's like at scale. So I'm not going to read all of this on here, but I am going to just tell a story, right? That takes into account all of this sort of stuff. So do stop me if you've heard this before. You go in fresh to an organisation, they're hiring their first DevOps engineer, yay, good for them. About 10 years ago, one of the developers heard of the concept of CI/CD. They got in Jenkins and they started doing it internally because they thought they could fulfill their own needs. Fast forward 10 years, suddenly every developer has an opinion on what this platform should look like. None of how the tasks are carried out are actually standardized or have some kind of forethought methodology before them. You do not have any clarity on who's doing things, what they're doing, why they're doing them, or how they're doing them. Right? If you want to trace when did this deployment to this environment happen and who done it, you can't, because it's too much of a mess. Right? And all of these problems stem from an architectural pattern that's quite old, from the 1990s, called the Big Ball of Mud, which I think is a really good name. So CI/CD platforms tend to be developed by DevOps engineers or cloud engineers or platform engineers or whatever the buzzword of the day is. But crucially, the people in them tend to come from more SysOps background. And so developing your own applications at scale and doing those sort of architectural patterns may not necessarily be something that they have experience in before. And so a lot of the early pains of software development we are seeing re-manifest in the tools and platforms and methodologies that DevOps individuals are proficient in. One of those is the Big Ball of Mud, which is kind of self-explanatory, but the idea there is that a system will emerge casually and haphazardly without any kind of architectural oversight or forethought, and all these sort of problems stem ultimately from the fact that the thing is growing organically. And that's fine if you're not operating at scale, right? Having an architect, putting things down, figuring out the hard problems of how to scale things doesn't matter if you're never going to scale. If you're only ever going to have 100 pipelines, then all of this is completely overkill, right? And so, as I go over all these things to scale, I just want you all to keep in mind, number one, read that paper if you haven't. The link's, actually, you can call me Benjamin, I've done something wrong. That's a link to my website. I'll be doing demos at the end of this. All of my demos are publicly available on my GitHub. You can go and peruse your code in your own time. I equally have a link to the research paper, Big Ball of Mud, on whatever the website is, ResearchGate or whatever it is, where you can go and you can download that. So scan that or go to my website and you can get access to the demos and that. But yeah, all of that stems from the fact that a lot of these CI/CD platforms fall into that pattern of there's just no foresight, which is fine if you're not at scale. If you are going to scale, then you need to actually start changing how you operate. And we're going to go over some ways you can actually put down patterns and working processes for that. So the first is really, really simple and perhaps boring, but it's structure and it's naming conventions, right? The questions of who's doing what and why they're doing it and where it's deploying to, you don't need fancy technologies or tools to figure that out. You just need to actually structure your house in order, right? And so at the end of this, I'm going to go over an architecture you can use to gain analytical insights into your platform, but there's no point observing your platform if it's a mess, right? So the first thing you need to do is have a sit down and think, in your organization, how do I structure things properly? What I have here is an example from Azure DevOps pipelines. You can see that in Azure DevOps pipelines, just because it's what I use most these days, that and GitHub Actions. We organize things by projects. That's just a conceptual business unit where you probably have dedicated resources to that project, dedicated teams or whatever. Underneath that, you then start to organize things by repos, right? So provided all your repositories have separation of concerns, and by that I mean repo A deploys product A, repo B deploys repo B, etc. Assuming that, then just by merely separating out your pipelines at that top level of project, okay, that's the business costs and whatever, then the repo essentially becomes the applications you're deploying. You can then drill that down further. Are you doing a CI pipeline or are you doing a deployment pipeline? The CI pipelines tend to be things like commit to pull requests, but also in there you can do things like this is my end-to-end regression test suite for the product in prod, in test, or whatever. And then crucially, just by structuring your pipelines properly for deployments, you can actually get that audibility and visibility into what's happening and where in your environment. Big thing about this, in programming there's a concept for magic numbers, just a random integer floating in the code without any context on what it does. All too often I see environments being the same. Someone will go, oh, I'm deploying to prod, I'm deploying to dev, deploying to test. Okay, yes, but prod, dev and test for app A, app B, app C, if you're at scale, are going to be different environments. It might be you're operating in a multi-cloud environment where you have 50 AWS accounts. And what is dev for app A will be different for app B, will be different for app C. What's prod will be different for app A, for app B, or for app C. Right? And so when you're doing this, always be explicit about where your environments are. If you're operating a multi-account AWS or Azure, for example, don't just put dev, put the actual name of the account so that you don't need to know the project or the repo or have any contextual knowledge to understand where this thing is actually operating at, right? Equally, if you have like physical on-prem data centers, name it after the location, right? Don't just call it dev, test, whatever. Be absolutely explicit so that a new hire on day one can look at your repo structure and go, that makes sense. If they can't do that, you've organised it bad. Organise it better. Stop it bad. You can apply this on Circle CI, so that allows you to group by projects and do this sort of structure. You can apply it on GitLab CI as well. The only sort of major contender out there you can't do it is GitHub Actions. They've had an open issue since 2022 because for GitHub Actions, all your workflows need to be in a flat file structure under a workflows folder. Absolute best, you can't do this pattern. But otherwise you can for the other major vendors out there. And that's really the only pitfall of GitHub Actions, otherwise it's quicker. So, with all that said, we've got some structure into our CI/CD platform. We actually know what apps it's deploying, where it's deploying them to, assuming you have good CD processes and all of these pipelines executing are linked to change requests or whatnot. Suddenly, just by having an actual structure, you go to it, you see the change request it's linked to, you know why that deployment's happened, bam, you've got your business context, no fancy tools needed, just some standards, right? However, pipelines do things, right? Shocking, I know. If pipelines are just a collection of arbitrary code, the next question becomes, okay, if my structure gives me some insight into where they're deploying, who's deploying them, what it's deploying, the next question becomes, how do I scale what's actually happening under the hood, right? And that becomes a really difficult question. If we go back to the example that I gave earlier, if you have people organically creating tasks and the way that repo A does a Docker build will be different to repo B, will be different to repo C, because they're all using inline shell scripts or bash scripts or whatever. If you want to standardize that and actually go, hey, well, we have a Docker specialist, they want to come in, they want to refactor this, they want to scale it out to all your pipelines. If every pipeline is doing it differently, then that becomes really difficult, right? So the next question becomes, how do we manage pipeline code at scale? And there's two models you can use for that. The first is the pull model. You can see here, I think, you can all see that right? Oh, I'm not blocking it. You can see here, the basic concept behind that is that you have a core library of reusable components that perform the business needs you're doing. Right? So that might be you are running Python quality checks, you're doing things like Flake8, Bandit, whatever, right? You're running unit tests, you're running regression tests. You might have Terraform, in which case you might be doing Chekhov or format checks or whatever. Or you might be doing Docker, in which case you're doing Docker builds, you're caching it in your internal Artifactory repository or whatever, right? The core CI/CD component library has reusable tasks in it, and then the pattern then becomes your repos that instantiate and actually have pipelines in them, they just plug together their reusable components, and wham bam, you're done, right? The hard work's done for you. I've got some examples here of how that may look. So in Azure DevOps pipelines on the top left there, the way that you do it is as a concept of resources. And so you check out this repo or multiple repos, however you want to structure it. You'll give it a name, you'll give it a tag, and then throughout your tasks, you'll just reference that tag, done. With GitHub Actions, you have to specify for each and every individual action the full path and the tag as well. I've made the assumption here you're using semantic tags because you should be, if you're not, you're bad. You can see there, you reference it all there, right? And the really good thing around this is that if we look back at our scaling panes, right? If your teams are having to handcraft every single pipeline, they're not really delivering the best value they can. Because if you have people that are specialists in all these different technologies, right? If you have something like this, you can say to them, okay, Docker specialist person, go and give me a set of reusable components to do Docker builds. Terraform person, go and give me a set of reusable components to do Terraform. And then suddenly you have a standardized set of components that may be reused across your entire organization. Really good real-life example I'll give you of this is a pattern or working process that I like to follow, which is make it work, then you make it right, and then you make it fast. Right? So I had to provision a bunch of MATLAB builds for a client of mine using Docker. The initial setup was just within this repository, make some pipelines that do the Docker builds. Done, they fulfilled their use case, great, happy days. Next step was, okay, let's try and make that right. So let's actually generalize that and abstract that into a reusable component, put it in this CI/CD component library, bam, good, done. Then let's make it fast. So after a couple of weeks, we noticed that task was not necessarily being the most computationally performant. However, the great thing about a reusable component is, just like any other software, you just define it in terms of the contextual dependencies, the inputs and the outputs. What happens inside is a black box, and so as long as you keep all of that, you are free to gut out all the internal logic and refactor it. And so for this particular use case or this example that I'm giving you, I was able to change the Docker builds to a completely different Docker engine entirely. I was able to do caching in there, the internal Docker repository. None of this was beknownst to the developers using the pipeline. They just got a new version of the tag, and suddenly their pipelines were 95% faster, right? Because you're abstracting everything away in this core component library. The second way you can do it is a push model. This is a lot rarer. I've only seen this in a few clients of mine. The reason for that is you need really good source control of your source control. So to do something like this, the concept is that, okay, in this model, you're kind of assuming the people in these repos, they're either people embedded in the project, or they're developers doing self-service, or they're maybe somewhat removed from your team, right? And they're consuming essentially your platform to fulfill their needs. What this model kind of turns up on its head and says, actually, we don't want people to make their own pipelines, we want to essentially control all of them and push them out into the repos, right? And you can do that. That is absolutely doable. You just need a really good source control platform to actually have that work at scale. So I have a demo of that actually later on GitHub, whereby I've got a commit to pull request bunch of validation checks. At the start of that, it reads in the file present in every repo that gives it a bunch of folder paths, and then it just uses a standardized pipeline to do everything. But for the most part, I probably recommend the pull model unless you really want to essentially control everything. That's all good and well, and that's kind of how you can piece together like the components in your platform that are there already. However, the platform you're using for CI/CD will have a bunch of blind sides. It will have blind spots, right, that it can't essentially do. And all too often, I've seen people fulfill that with just lines and lines and lines of bash, right? One client of mine that I went into, their core CI/CD platform was 8,000 lines of bash. Awful. Do not recommend. My entire contract there was turning that into a Python CI application because 8,000 lines of bash is not extensible and doesn't work. So one way you can plug internal gaps in your CI/CD platform is you can create your own internal CI tool. I started on a demo of this. I was planning to do one, but I planned about 5 demos. I only got about half of them, so I can maybe do a demo of this at a later talk potentially. But the core idea here is that you have your own internal CLI application that plugs in those gaps in the platform. So a really good example would be if you have a development team internally and they've developed some kind of app that has its own REST API, and as part of a deployment, for example, you want to send a post request to that REST API, right? Rather than have that in bash and someone puts in a plain text password or whatever, right? You go, oh, we're going to create our own specialized internal CLI tool that interacts with that application, and then all you do then in your core component library is you just instantiate that tool and then use it. So essentially you create a low-level wrapper around your commands, which is your CLI tool. You then create another level of abstraction in your core component library where you then use that tool to do things, right? So a really good example, real life example of this is if you use Azure DevOps pipelines, you can't do comments on pull requests. It's just not a built-in feature, right? It's awful. However, the Bitbucket REST API does let you do that. However, if you were to do that with a bunch of curl commands, you're having a bad day. And so you could instead, this is something that I built for one of the clients of mine, create your own internal CLI tool to insert that REST API to fulfill a need, instantiate that in your core component library, and suddenly your entire organization has the ability to put comments on pull requests where otherwise you couldn't, and you've done so in an extensible manner, because one of the other upshots of this, right, is if you've got your own internal CLI tool, all the usual best practice around quality, like unit testing, regression testing, all that stuff applies. Right. So that's good. Some results of this. So this whole thing is a package. I've implemented at various organisations now. Probably our most successful one is about 8,000 builds a month, over 1,000 partners and growing, with developers self-serving. So a core component library of tasks that fulfill all the generalised use cases for inputs and outputs, and then developers on hundreds of projects self-serving their needs, and that platform is now production critical for that client and has thousands and thousands and thousands of builds, right? So it's not hot air. However, if it's all structured like that, and that's great, and this is the demo that I wish I did have time to do, but I didn't, the next question becomes, how do you get observability into this, right? So if you suddenly have scaled to, let's say, 3,000 pipelines, right, this structure here is fine if you're going into the CI/CD platform and trying to organise things. If you want to, say, aggregate, for example, my deployments to environment A across every single pipeline, this becomes a bit difficult to do. However, luckily for us, every modern CI/CD platform is event-based. So by that, I mean, if you do a commit on a pull request, that's going to trigger an event on your platform, that will trigger a build, that build state may change. You then, if you know about state machines, just follow a state machine. Each change in state triggers another event in the CI/CD platform. And thankfully for us, as DevOps engineers, platform engineers, cloud engineers, whatever the name is these days, majority of platforms expose that as webhooks. So GitHub Actions does it, Circle CI does it, GitLab does it, Azure DevOps does it, right? You can subscribe to webhooks from all of these platforms that will give you information about these builds at runtime. And so, again, this is a solution that I put in place for one of my clients that had that humongous amount of builds. It's really, really simple. Basically, at its core, it's just a REST API in the cloud. But the data you're ingesting from that with your user ETL processes are the events of your platform. And if you build that properly, which I wanted to get a demo of, but I didn't, sorry, you can start to aggregate things and go, oh, well, if you have that core component library, you have something like this, you can start to go, which tasks of mine have the higher percentage of failures? Which ones run the longest? What are my busiest pipelines? What are my busiest projects? And then you can actually target your specialist resource to those areas where you're going to have the most impact, right? Rather than going on a gut and going, well, I know the business owner for this project yelled the loudest this month, so I'm going to work on their stuff. You can actually go, well, actually, this platform here tells me that this particular task here is running on average, say, 20 minutes a task, but I know I can get that down. You can focus those efforts, and then you can actually use data to not only target your efforts, but to see the results of them. If you do that, and you then, say, for example, reduce the time of that task to like a minute, you will have the raw data to back up to actually show that that's worked. Right? So that's a really good sort of cherry on top. Once you've got a structure, you've got your platform at scale, implement something like this, you're laughing, right? You can start to build dashboards of single pane of glass of what's going on in all your environments. So, all that said, it's probably demo time. Now, my laptop did crash when I opened my last demo, so hopefully that doesn't happen this time. But I have 3 demos for you. I have an example of a GitHub Actions composite action library, which is just that core CI/CD component library of reuse. I then have a core feature which is how to document that library. So if you have an SDK for traditional programming language, right? You're going to have documentation around that. That means that people using that SDK don't go in the code to figure out what it does, they just read the documentation. Equally, if you have a CI/CD platform at scale, it should be well documented. If it's not, write a document, stop it. But this is a good pattern you can use to have an online documentation library that the likes of Microsoft and HashiCorp and GitHub all use. It's the same process, the same workflows, the same tooling that they use under the hood. You can have that too, and you can build up a demo. And again, this is all available on my GitHub, so dive into it in your own time. And then finally, I'll show some example of the usage of that core CI/CD component library to actually do some things. So, that said, I'm going to hope my laptop doesn't crash. Yay! So we can see, okay, yes. Here, an example core action library. You can see the layout is relatively basic. I'll scroll up a little bit on here actually. You can see the layout is quite basic. For GitHub Actions, your composite actions need to basically be separated by folder, and they have to have an action.yaml file inside that folder. Whereas if you have something like Azure DevOps, it's the name of the file. They will differ slightly, but it's the same concept as the hood, right? You can see here I've got a standardized plan and standardized plan for Terraform. I've got a good doc string at the top there, what it does. I've got all my inputs defined. I do some stuff, and happy days, we're all there. And I've got an apply there as well, which takes the output of the plan and actually applies it. Ways you can document that, like this. So this was made using MakeDocs. So one thing that I'm very keen of in my role is I like documentation. If you ask anyone who's worked with me, I document the hell out of everything. Far more important things in my head than computers, things like what's for lunch. I want to focus on that. So you can have a documentation like this, and you can see here, you just get like a home, you've got a little getting started section with a little layman's explanation of what actions are. You have an example of how to utilize it. You've got some release notes. Always have some release notes, and then you've got the actual actions fully documented under here with the inputs, the syntax, how to use it. All the inputs are well defined, the outputs are well defined, and then an example usage within a matrix so that you can, for example, do plans across multiple environments here as well, right? So this is another good thing as well. You couldn't do this if every single pipeline was an own custom use case that was created, right? You can only do this if you have a core set of components you're reusing across your pipeline. So it's another advantage of that pattern is that your stuff actually becomes well documented with a known interface, known contextual dependencies. If you went to my last talk in Terraform, you know that I love talking about contextual dependencies and inputs. You have to document them. You can see an example usage here, which did crash last time, so hopefully it doesn't this time. You can see here in my deployment workflow that my Terraform plan is simply using version 1 of my core CI/CD component. Now this is just a plan, right? Under the hood, that's also doing things like ensuring security compliance, ensuring formatting, ensuring all that sort of stuff. It means that as a team, you can really start to enforce those standards and compliance across your business in a way that you just can't do if you don't have a core library like that, right? Yes?
Zoom in the time.
Sorry.
Did you zoom in the time?
Oh, yes. That's not the right button. Oh. Does anyone know keyboard shortcuts on PyChart?
Come on, yes.
I tried that, it didn't.
Come on, shift.
Oh, okay.
Sorry.
And then check. Go back to the
Yay, there you go. So, can you see that now? That way, cool. So as I was saying, as you might not be able to see before, thanks for putting that out. My plan just consumes the core CI/CD component library and that task at that version. I've abstracted away all the complexities around ensuring security compliance, ensuring standard compliance, all that sort of stuff. In Terraform, it's quite basic. If you do things like application code, you can get a lot more fancy where, for example, on what I've seen is that on a commit to a pull request, you have a standard set of quality checks under the hood that's actually cobbling together like 10 different platforms to do things like static code analysis, code coverage, all that sort of stuff. Yeah, that's an example of continuous delivery because we're doing the plan, we're waiting for approval, and then we're doing the apply, we're not just throwing it into production. And that's the one on screen. And I've zoomed in early this time. And here you can see just a really basic example of continuous delivery, which is different, where this is a core Python library. That was one half the demo I wanted to do, but ran out of time for. But you can see that on a release to GitHub, on release from GitHub, we describe the release tag, build and push our core library, create the documentation, and push it up to both documentation and PyPI. And that's it. Questions? Do you want to check this?
Ask if anyone wants questions.
Questions? You have to speak up now. You can't hide behind something. Yes.
So you have the step there that waits for approval. Is that? Could you show that one? I was looking for something like that.
Yeah, it's a built-in component of GitHub Actions. Sorry, it was the other one, wasn't it? Yeah, this one here. The way that this one works is once it's there, it creates an issue on the repo.
Yeah.
It then waits for a bunch of a comment from the approver on the repo to say it's approved, and only once it's done does it actually work. If you look at I believe this is the modularized repo. You see here the way it works is it creates issues to say I need manual approval for this, and only only if we get these keywords will we actually approve it. Classic LGTM. But yeah, other platforms have built-in tasks. I know that Azure DevOps has a built-in task. I know GitHub has one. I'm not sure about those, but I'm sure they should. Cool. Any other? Yes.
Yeah, you mentioned that GitHub Actions has a certain limitation that the platforms don't. If I understand it correctly, is it that all of your actions have to sit inside the .github folder? Is that the only limitation you?
Yeah, so the only limitation so the core CI/CD component library, no limitations at all. You can use that pattern. The issue with GitHub Actions is that all your workflows need to be, or all your pipelines need to go into this one workflows folder. So that structure I've shown you earlier, where you drill down by, CI or deployment and environment and stuff, you can't do. They have an open issue for 3 years with a lot of angry comments on it. So hopefully you get away from it, but we'll see. Yes.
Sorry, so how would you much rather structure it? Would you structure it by application, like service, and then inside of that service you would have the deployment file for that service?
So the repos should have separation of concerns. So repo A is at A, repo B is at B, etc. So you've already split it by application. The problem then becomes how to organise these. That's going to look different in every organisation. I think one way you could do it is with a sort of standardised naming structure, where you have, for example, ci.thing.thing.thing, just like you basically namespace the file. I think is the best way you're going to get to do that, because then things like ls on Linux you could filter out and grep for certain things, and in the GUI you could see that as well. But again, the same limitation happens in the GUI for GitHub Actions, because all the workflows are justified. Show you. I don't know why it doesn't. When I click on Safari, it doesn't go to Safari. It's amazing. Yeah, all the. You can see I tried it and it doesn't work. All the things are one thing. But if you use something like Azure DevOps pipelines or GitLab, you can actually structure that in a more formulated fashion. Yes?
What about security tool? Have you integrated any SaaS or DAS tool?
Yeah, loads. So the good thing about having the core component library is if you're saying, oh, I know my developers are using Python, what that allows you to do is give them a standard set of Python quality checks that can then integrate those libraries, right?
Mm-hmm.
So what have I done personally? Bandit for static code analysis and vulnerabilities, Flake8 for formatting on the main two, and then for something like Terraform, Chekhov for security vulnerabilities, for Docker build something like Trivy, which is open source again. But the good thing about having the core CI/CD component library is your developers don't even know about that. You can just give them a standard set of tasks, and you, as the specialist in the domain, can go, well, actually, you should be doing all this stuff, and so I'm going to force you to. And if it fails, that's your fault. Go fix your stuff. Does that answer your question?
Yeah.
Kind of.
So have you used any tool, security tool, in your pipeline?
In the ones I'm demoing, I've got Chekhov, I think. No, just check. I think that's Chekhov. Yeah, so I've got Chekhov's open source. Just pick and install it, and then run some scans across there, and then output it as a file that then gets consumed. If you're doing something like Azure DevOps and you output it as JUnit, you can then have like a test visualization platform to get visibility into that. Cool. Is that what you're cool, amazing. Yeah, yes, what about that?
I've got two questions for that last two.
Greedy, okay.
First one, people like this. Mono repos. How do you deal with that with this setup?
So there's no so first of all, I'm going to preface it with saying people will go use a mono repo or use a micro repo. There's no right or wrong answer, right? It depends on the business context, depends on the way that you're working, right? There's no, mono repos have their place, micro repos have their place. Stop arguing about them, do the thing. The way you do it for mono repos even, is your issue there then becomes if one repo has 5 applications in it, right, you then still need a way to deal with separation of concerns within that. And so there's only one small difference you would do, which is that if I click back, within the repo, you would just then further split it by application, and then underneath that have all this standard stuff here. So if repo A has app 1, 2, 3, 4, you just have sort of a top level folder 1, 2, 3, 4 under that, and then under them you split it.
So that's easy enough in things like GitHub Actions, but using GitLab, it seems to be quite constrained with a single pipeline YAML.
Okay.
You have to do quite a lot of scaffolding just to get past that on one of the repos.
Okay, I haven't got a demo in GitLab, so I can't necessarily show that. It should be possible, but I
it's
can't.
possible, but it's a pain in the butt.
Yeah.
It's disgusting.
It's there's going to be differences in implementation depending on the platform, right? I haven't used GitLab in about 5 years, so I can't quite remember how I've done it, but it is.
Just call it the inputs that you need for you can have sub pipelines, but like it looks like it's like Lambda, right? You have to make everything yourself.
So just one example. Actually, I can't show it here. If you've got a short, you see all my speakers notes. No, it's the magic. If you're using like Azure DevOps, one way I'd have it is I'd have a root template deployment pipeline. That is just so you have your core CI/CD components. For repo A, you have a core template way of deploying that repo, and then you just instantiate it for different environments. I'm afraid I can't answer with specifics. No, it's worth asking.
Second one, given components, something that I've been considering too. How do you test them?
So that's a good question. So if those components, for example, are wrappers around a core CLI application, test is easy. You use the normal unit or integration or regression testing. If you're having your core reusable components, what I would say is you need a set of pipelines to test the pipelines, right? And so within that one particular core component repo, I would argue you probably need a pipeline that tests each component and then have that trigger automatically.
So is there any frameworks or kind of,
Pardon, sorry?
is there any frameworks or kind of templates you use to test your components then?
I've just structured it manually. I mean, it depends. So, GitHub Actions, for example, you can run components locally in Docker. So I could use something like the Behave framework in Python to have like a nice markdown table and say do this, do this, do this, do this. In terms of any specific frameworks, only the patterns I've defined myself. I haven't sort of grabbed something off the shelf and used that to test it. Cool. Does that answer your question? Perhaps not well.
It's basically what I would do, just wing it, right?
Well, as long as you structure it, right, properly, and say you've got a repo with here, you've got these actions here, right, you would have a set of pipelines within here that then test each individual action. And that's where things like quality control come into play, right? So if you have a core CI/CD component library, you can gate that behind a pull request. You can then gate that to say, hey, yeah, you've made your action, that's great, but have you tested it? And so nothing becomes a semantic version until you've proven to your peers, basically, you're not just winging it, and it works.
Yeah, I'm just worried that the pipelines to test the pipelines is going to end up like the bash example where it's going to be thousands of lines because you'll be covering all of the use cases.
Yeah, it depends. So in practice, what I've seen is that the pipelines are tested, so the components are tested when they're made, but regression testing doesn't happen, is what I've seen. So like the initial pull request to a component library, you would say to somebody, you know, yes, you're adding action plan, right? How have you tested that? Show me a pipeline out there in the world that uses that core component, that works, tag it, ship it.
So that's a lot of manual. You know, so one of the big things with CI/CD is it's automated, but how to do that is quite manual.
It is automated, but you still have to write code. It's you can, but I won't do it well. So it's the thing about scale, right? So if you're applying this pattern to 50 pipelines, probably not effective. If you're applying it to 1,000, that effort becomes worth it because the value you're gaining out of it is worth it. So one thing to keep in mind, I think I mentioned before, is the essential complexity of your refinement, right? If you have a simple problem, give it a simple solution, right? These sort of patterns, like I said, are intended for thousands of pipelines, tens of thousands of builds, right? If you're operating at a smaller scale, it's absolutely applicable. It then becomes your own business decision of, is this effort worth it within my environment? And that's something only you can answer right. So. Any other questions?
What about permissions? How the permissions are implemented?
In terms of like the demos or?
No, in terms of, for example, the different teams are using this, like how the permissions have been maintained, the structure.
Yeah, so the way that I'll do it is that specialist teams have access to the CI/CD component library. They can add new components. So like your DevOps, your cloud, your platform engineers, they can create new CI/CD components in that library. The way that I've seen it again at this scale is that developers will then self-serve their needs and create their own pipelines with those reusable components. So the sort of demarcation there is that your specialist sort of CI/CD teams create the platform, your developers then consume it as a service, is the pattern I've seen most. Thanks.
So, we've been discussing about CI/CD at scale, right?
Yeah.
So what are the key metrics we need to track to make sure everything is healthy? For example, deployment frequency, self-failure.
So deployment frequency is a classic. That's also a DORA metric you might be tracking separately as well. I think as well failure rate is a big one, but I think release cadence can actually act as a proxy for a lot of things. If your developers are releasing faster with less bugs, that's probably an indicator you've given them a platform to, for example, do more efficient regression testing, do more efficient deployments, do all that sort of stuff. I would say in terms of whether such a pattern is worthwhile, I'd probably go for quantity and complexity. In terms of once that pattern is there, how do you sort of manage the health of that? I would say things like failure rate and release cadence. But also one of the really good ones is you can start tracking people hours saved. So that's a really nice one, right? I mean, the sort of work we do is sometimes seen as a cost center. If you can turn around and go, well, actually, this platform saved the 600 people days this month, it becomes much easier to do. Does that answer your
Yeah,
question?
so partially, but so if in case, right, we've been discussing about the enterprise grade, right? So, if someone, for example, right, if you create your own startup, you want to build your fintech startup tomorrow, right? What kind of setup you implement when it comes to CI/CD?
I would still do the pull model because having, especially for a startup, you don't know how much you're going to scale really. You could get lucky, get a load of seed funding and suddenly your team grows 50%. Or you could not get lucky and you go bankrupt in 5 years. However, I think the pull model is the most flexible because all you're ultimately doing is shifting left your CI/CD definition into a core component library and then reusing it. Now, you may only reuse it in 4, 5, 6 pipelines, but I still think that adds value because it really lays the groundwork for growth. And if you expect your teams and your platform to have the growth, it puts you in the best place for that. If you don't expect to have growth, then maybe it's not worth it, but equally, if you're not expecting growth, you're not much of a business.
So as you said, right, it's shift left. So in this process, right, there are, if you look at GitLab, right, there are certain tool chain that's being implemented, right, by default by GitLab.
Yep.
So where dedicated implementation of DevOps is no more required for any startups until they become scale up, right? In this scenario, do you think we need to have at least fractional DevOps guy to set up the process, or the developers can just go and use the tool chain of GitLab where they implement,
They can use it.
CI/CD, artifact registry to, anything you can imagine.
Yeah, they can use it. So I think that's more a fundamental question of bringing DevOps into business, right? And I think the answer to that is definitely when you tend to scale more, right? If you're a small team, you can probably get away with developers self-serving their needs. However, the second you start to scale, and scale is such a arbitrary use term, but when you double, triple, quadruple your team, you start shipping more and more products, you get more revenue, you need more quality. That's when you need to start having a dedicated resource. And it's what I went back to earlier, right? The big board model architecture is perfectly fine for small scale. You don't need anything more than haphazardly copying things together if you're a small team. That's absolutely perfectly doable, and software has been made that way forever and will continue to be made that way forever. If you want to scale, if you want to lay the groundworks, I don't think you need a DevOps specialist to do this. I think this is a general pattern and framework of working, and it's an architectural style of CI/CD. You will get the most value and benefit of a DevOps specialist because they'll be best placed to sell this to your business owners, implement the tasks you need, but you can still do it with developer self-service. And arguably that takes pressure off your DevOps teams as well. So I'm afraid a nuanced answer to your question. Oh goodness, two. Okay. I think you went first.
Mine is completely non-technical. You might be pleased to hear it. Not pleased to hear. I see there's a recording device there. Are these two fantastic talks going to be available for us to rewatch at some point?
I'm going to delegate.
Probably next week. Probably next week at some point.
Okay. And how do I find out about that through the link?
The YouTube, my friend. So I'll send you a link. After I'll send you a link.
Okay. Cool. Thank you.
Right.
Great talk, by the way.
Nice. Thank you. I believe you have questions.
Yeah. So because we have so many tools out there, like we have, for example, Circle CI, Travis CI, Team City, and then we have GitLab CI, GitHub Actions. On top of that, we have cloud-based solutions. Each cloud offers their own CI/CD. So if you are a startup, which options would you go for? As your CI/CD solution, or
that's a hard question.
like working with your clients, have you noticed
with my clients,
their experience?
Yeah, so if they're a Microsoft house already, for sure DevOps is a good one because you tend to get discretionary licensing costs, and that's always a factor in business, right? Cost is something you might like to think about, but businesses exist to make money, so you have to factor that in. So that's a good one. I also think in certain aspects it's more mature than GitHub Actions, which is shocking to say, but that flat file system one really bothers me. I probably wouldn't recommend Team City. It's a bit clunky, it's a bit of a heavy setup. I think if you're just starting out, if you can, something that integrates closely with your source control platform is useful. So if you're using GitHub, GitHub Actions is a natural fit. If you're using Azure Repos, Azure DevOps Partners is a natural fit. If you're using Bitbucket CI is a natural fit. If cost is a factor, go the cheapest. If functionality is the factor, look into your use case. If you don't expect too many complex pipelines and you just want an estate, go for GitHub Actions. If you want to self-provision using Kubernetes, your own agent cluster, and you want to have full in-house control of the tasks that execute, then something like Azure DevOps is a good option.
Yeah, great.
Yes.
Just one last question.
So many questions. Right?
Last one.
Just wanted to ask, like, can we use custom build workers instead of using the GitHub ones? Like,
Yeah. I mean, I guess I should expand on that. Yes, you can. So, it's something I've done for clients of mine, especially who have compliance needs where you need to run your stuff in-house. You can't just be running it on JBog server in the cloud, which is some nebulous shed in somebody's back garden. Right? You need to run it in a known entity using a known compute environment. Yes, you can. So they tend to have Docker images as a base, and you can pull from them. Equally, a lot of the tool chains that are used tend to have Linux packages and also Windows packages. My own experience is primarily with Linux, so that's where I'm most comfortable. But you can do it in Windows as well. But the key thing to watch out for is taking Azure DevOps as an example. They have an entire toolkit around how you can provision your own Azure DevOps agent. You will need connectivity from whatever your agent is into your CI/CD platform, because, like I said, that event-based architecture that I gave for getting your own analytical insights is the same one they use to schedule jobs. So you need some way to get data from there. Once you have that, yes. Cool. I believe that was the last.
That's it.
Yes, okay.